What is a phase diagram? A phase diagram is an actual plot, a plot of different conditions of pressure and temperature that help you locate the phase in which a substance can be found. So you're going to be plotting temperature and pressure, and then you're going to be looking at the different phases in which your substance exists. You change conditions of pressure and temperature. You're mapping different regions. You ended up with this yellow region that you know because of observation that the substance exists as a gas. Now you do different experiments, and by observation you know that under certain conditions you create a region where liquid exists, and so on. Similarly for the solid. The same substance, but now you will have different phases according to the different types or the different conditions of pressure and temperature. This is important in many applications. We're going to discuss this, but have that in mind. It's actually very important to know the phase diagrams for different substances. What you need to know about the basics that you need to know about phase diagrams, particularly for phase diagrams of one component, unary components. Equilibrium lines. We already discussed that there are certain regions that has these solid, liquid, and gas phases. But the separation between those two are given by these lines that we see here in white. So each of these lines are separating two phases, meaning that in these lines there are coexistence of two different phases, depending on what phases you have at each side of the line. So in this case, you're going to have coexistence between the solid and a liquid, and between a liquid and a gas. So that means that in this coexistence liquid-gas, this is actually a boiling point. But then this is also boiling point, this is also boiling point, this is a boiling point. So the coexistence of two different phases for this line makes these boiling points not being unique. They depend on the pressure at which each of them are measured. Triple point. Triple point is this one here. We're looking at and we label it as A. That is actually interesting because what we know is that in this one point, these three lines are converging. So that means that this point actually is touching the solid, the liquid, and the gas phases all together at the same time. So you have three different phases, and that's why you call it a triple point. Now, a critical point. The critical point is this one that we are labeling here as B. That is very interesting because above this temperature of the critical point, the densities of the liquid and the gas are the same. Because they're the same, then you cannot tell them apart. So it's not a liquid, it's not a gas, but in this region here, you are finding a new phase that we call a supercritical fluid that has characteristics of both the liquid and the gas. Normal boiling point. Normal boiling point is basically is referring to a boiling point, but remember, in this line you have many different boiling points. The key here is that the normal boiling point is exclusively when you're reading at 1 atmosphere of pressure. Boiling point, boiling point, boiling point, but if one is read at 1 atmosphere of pressure, that's the only one that we can call normal boiling point. With normal melting point, something similar happens. It's only referred to 1 atmosphere of pressure. So here along this line, we have melting point, melting point, melting point, but only the one that it's measured at 1 atmosphere of pressure, it's going to be called the normal melting point. Okay, you should be able to identify all of this in a phase diagram, either in an exam, in a homework, in a quiz. You should be able to identify all these basic points in a phase diagram. That's very important. Critical point, it's actually interesting because what happens with this critical point is that you define these conditions of pressure and temperature for the critical point, and then you know that the density of the gas is equal to the density of the liquid, then you get a supercritical fluid. Then that means that above this temperature, okay, above this temperature here, it doesn't matter how much you can increase the pressure, you're never gonna get a liquid. You're always gonna get a supercritical fluid, okay? That supercritical fluid is different from the liquid. It's different from the gas. But if, for example, you are in this region of the phase diagram below the critical temperature, if you increase the temperature, your substance is gonna go from the gas to the liquid phase. Then you can actually condense the gas. But above this critical temperature, you cannot. You can actually see it in this diagram, where below the critical temperature, you can see the separations between the two phases. You have this interface, but then once you go above the critical temperature, that interface goes away. Now it becomes one single phase, a supercritical fluid phase.